Okay, we go to case 2. Integrals of the form secant to the n u du or cosecant to the n u du, where n is a positive even integer, even and positive. So the rule is to factor secant squared u, or in the case of cosecant to the n, factor cosecant squared u, and apply the identity. We apply the identity 1 plus tangent squared u equal to secant squared u, and 1 plus cotangent squared u equal to cosecant squared u to the other factor. So after factoring secant squared, the other factor should be expressed in terms of tangent or in terms of cotangent, so that eventually we'll be able to use power formula or any other fundamental formula. So, example, say the integral of secant to the fourth 2z dz. The rule is to factor secant squared. So secant squared 2c dc, okay, secant squared times secant squared. And we preserve secant squared 2c dc because we know that that is partly the differential of tangent. So we shall apply the identity to the other factor secant squared, which will become 1 plus tangent squared 2c times secant squared 2c dc. Then we distribute, we'll be getting two integrals, secant squared 2c dc plus tangent squared 2c secant squared 2c dc. The first integral is a fundamental one, no? Secant squared u. Your u is 2c, so it blocks 2, you place 1/2. 1/2, integral of secant squared is, of course, tangent 2c. For the second one, we use the power formula. So your u is tangent 2c, and your du is secant squared 2c times 2 dc. Again, the missing constant, 2, 1/2. So plus 1/2, and u squared becomes u cubed. So tangent cubed 2c all over 3 plus c. Final answer, 1/2 tangent 2c plus 1 over 6 tangent cubed 2c plus c. If you want, you can factor that, the constant. So 1 over 6, 3 tangent 2c plus tangent cubed 2c plus c.